Hi everybody, welcome back to our series on LiDAR and Climate Adaptation Planning. Today we're going to look at how LiDAR data is collected and how is data useful in watershed planning. In our previous video, we mentioned that LiDAR is useful because it captures small differences in elevation. In the prairies, this is really important since the slightest slope will determine in which direction the water will run. It runs downhill, right? And during the spring melt, this could be the difference between staying safe and dry or having water coming up to your doorstep where you think you got to tie a canoe to the step. So how does LiDAR uses lasers to collect ground elevation data? Good question. An aircraft mounted with a LiDAR sensor flies over the area we're interested in. The location of the plane is tracked by GPS, which will capture the location, the speed, and the direction that the plane is flying. The LiDAR rangefinder laser uses pulses to capture the elevation. A pulse is a burst of light that goes in a straight line, reflects on an area, and then bounces back to the plane. The system records the time taken for the pulse to travel to the ground and back. And we know that light travels, well, at the speed of light, right? So we can use the speed and the travel time to calculate the distance between the plane and the ground. Now that we have the distance, we can calculate the elevation. If we record the altitude of the plane and subtract the distance between the plane and the ground, the one that we calculated using LiDAR, then we have a record of the ground elevation. Before this information becomes a data point, two corrections must be done. Most LiDAR pulses travel at an angle, so our system also records the angle to correct the measurement. So also winds and light turbulence make the plane move and roll a bit. These movements are tracked with the Inertial Measurement Unit, or IMU. And the IMU corrects any movements of the plane to give us precise measurements. LiDAR data is a combination of the information transmitted by the laser rangefinder, the GPS coordinates, and that IMU. All this raw data is recorded on the onboard computer. Because LiDAR captures very precise elevation data, there is a short period of time when we can collect accurate data. Usually spring and fall seasons are best, especially when there's no vegetation or no snow. However, things like floods may distort the elevation survey, high winds, blowing snow, or dust in the air, which also interferes with the quality of the data. So the next section is truthing the data. So this data needs to be processed and truthed before we can use it. And once it's collected, we have a large amount of raw data that needs to be processed. Finding the ground truth or truthing is a way to calibrate and fine-tune the data collected to the landscape. Important features may not have been captured, and this is the time for correcting or adjusting data, which will include things like culvert inventory and submitting where all the culverts are so that we can understand the flow through of the water. The LiDAR data sets and files that you would expect to find and work with could look like this. This may look confusing at first, but we will learn how to use this information. In fact, Manitoba Watershed Districts currently use LiDAR data for floodplain mapping, drought consideration, or watershed planning. They are the local expertise that are on the ground. Unlike municipalities, water district borders are determined by the basin or the watershed they're responsible for. In this sense, their boundaries may overlap with several municipalities. Remember, water has no boundaries, but municipalities do. So let's hear from some of them.
Hi, I'm Jody Gertzen. I'm the Watershed District Manager for the St. Rat-Roseau Watershed District in southeastern Manitoba.
Hi, I'm Colin Gluding, the manager of the Northeastern Watershed District.
And I'm Sean Gertzen, Executive Director of Manitoba Association of Watersheds.
So what is a watershed? Well, a watershed is an area of land that captures all the rain. And if you picture an upside down umbrella and all the rain that falls into that umbrella would be the catchment or the watershed area.
A watershed district is made up of various geographical regions of Manitoba. Each district has a board of directors made up of municipal councillors and representatives from municipalities that are voluntarily part of the district. And watershed districts, they work with farmers and local communities to do watershed management. So to help build the resilience of our watersheds to climate change, to flooding, to droughts, to protect biodiversity, and a range of other issues.
Watershed Districts' strength is that it's a grassroots organization. It's local people making decisions on the landscape, and it's governed on a watershed basis, obviously, and not a political boundary basis. So that's a very important part of a watershed.
Watershed districts are a partnership between local farmers, landowners, community members, municipal councillors, the province of Manitoba. The federal government comes in on certain project-based funding, and there's other nonprofit organizations as well. So a wide range of partners come together on watershed district projects.
The watershed planning is just planning on priorities with respect to water management, surface water management, groundwater management, natural area preservation. Those things are all considered, and it's managed on a watershed basis. Each watershed will have its own differences and significances, so it's important to realize that and manage accordingly.
What it is it's basically looking at all the stakeholders in the watershed to develop what the assets are for that watershed and what the critical points are for protecting those assets, and then possibly the barriers to that protection, and then defining a strategy on how the stakeholders can work together with the watershed district as a lead planning authority to implement those important techniques.
You know, they don't just benefit one municipality, they benefit all of the municipalities in this watershed.
So LiDAR is important to the watershed districts because it helps us prioritize projects. It helps us use local knowledge to maybe confirm or maybe deny an area that is thought of as a potential project area.
LiDAR is really important because it helps us delineate the watershed lines, so the boundaries of where the water is coming from, so we can analyze how much water a retention cell is going to carry and what the impact is going to be for the local landowner and also for the downstream landowners.
Project we're standing on right now, we use LiDAR with the province of Manitoba to determine that this could actually work as a functioning retention site. We also were able to prioritize 18 other areas within the Cook's Devil's Creek watershed that all could be potential water retention areas. So provides great services to the watershed.
With LiDAR, we're also able to optimize and strategize to target our implementation for the best benefits and to reduce the impacts adversely for the most people.
I think LiDAR really complements the decades of knowledge that the watershed districts have, that their board members have, their staff like Colin, that the producers have in the area. All those people involved really know a lot about how water flows in their watersheds, and LiDAR just complements that. It adds hard data to what they already know. So it's a really important scientific foundation for watershed districts and other groups to be able to operate and do effective projects.
I want to give thanks to Jody, Sean, and Colin for all they do in their watersheds. Within the Red River Basin, we have a total of 5 watersheds. And what they bring is they're the troops on the ground. They're the big part of building success. And collectively together under a partnership, we work really well together. So in this section, we learned how LiDAR data is collected. And we learned what watersheds are all about through some of the watershed managers within the Red River Basin. In the next section, we're going to learn where you can locate LiDAR data to download for the areas that you're in. So stay tuned, and we'll see you for the next video.